Welcome to this lecture on use of ICT in education for online and blended learning. This is AICT approved faculty development program run by IIT Bombay. This lecture is for the creating video for the own classroom. The subject chosen is digital signal processing. Topic is classification of systems. At the end of the lecture, student will be able to, number one, understand and define memory, causality and linearity concepts of the properties of systems. Secondly, student will be able to explain and classify static versus dynamic, causal or non-causal, as well as linear or non-linear systems. This is our lecture plan. We'll see first what is discrete time system, then we'll go one by one to the static dynamic, causal non-causal and linear non-linear system. So we can see that this is a discrete time system. Discrete time system transforms the discrete time input signal into the discrete time output signals. If the input-output pair is defined as xn and yn respectively, then we can say that yn is equal to the transformation of x of n. That means if we give xn as an input signal, discrete time system will convert it to the output known as y of n. This is first of the system, static versus dynamic system. A system is said to be the static, or in other words memoryless system, if the response is due to the present input alone. That means the output at instant n depends upon inputs at distant n only, but not on the past or the future values. Let us take an example. The first one is yn is equal to xn, and the second one is yn is equal to 2 times x square n. In both the cases we can say that the input is at the instant n only, and that drives the output at the nth level. The same is true with the second one, and hence we can say that both the systems are the static systems. At the same time, if we take an example, y of n is equal to x of n minus 1 and y of n is equal to x of n plus x of n plus 3. In both these cases, we see that here that time instant input is x of n minus 1, here it is x of n plus 3. So that n output depends on sometimes on the past input, sometimes on the futuristic inputs, and hence we can say that the system is the dynamic system. Let us go to the second classification, that is causal and the non-causal systems. A system is said to be the causal, that is a non-anticipating, if the output at the instant n depends upon the past and the present inputs only, but not on the future input. So here there is a correction one can do. Causal systems are physically realizable systems, and input response for the causal system is 0 for n less than 0. That means h of n is equal to 0 for all n that is less than 0. Let us go to the examples of causal and non-causal systems. Y of n is equal to 2 times x of n plus x of n minus 2. We can see that output yn depends on the present input, that is x of n, and the past input, 2 samples past input, that is x of n minus 2. In the second case, that it is a static relationship, that output at n depends on the input at the instant n only, and hence we can very easily say that the both are the causal systems. On the other hand, if we take that y of n is equal to x of 2n, so we can see that if we take n is equal to 1 here, then y of 1 will depend on the x of 2 into 1. So that is x of 2. So we require a futuristic input. So that's why we can say that it is a non-causal system. Similarly here in this case, y at 0 will require the input at x of 3. So very clearly we can say that both the systems are non-causal systems. Now let us go back to the third example, that is linear and non-linear systems classification. System is linear if it follows homogeneity and the superposition principle. Homogeneity property means that if the system produces the output yn for the input xn, then it must produce the output a times yn for the input a times x of n. Similarly, superposition property says that a system which produces an output y of n for the input x of n and y to n for the input x to n, then it must produce the output, that is y1n plus y to n for the input x1n plus x to n. So if we combine these two properties, then we can say that the system is linear if an arbitrary input x1n produces the input y1n and the input x2n produces the output y2n. Then the weighted sum of the inputs, that is the a times x1n plus b times x2n, must produce an output, that is a times y1n plus b times y2n. That means that transformation of this combined or the weighted input is equal to the linear scaling of the individual outputs y1 and y2. So we can say that the system is linear if the output due to the weighted sum of the input is equal to the weighted sum of the outputs. Let us see the examples. First example is y of n is equal to x of n square. Here we can say that if that input is x1, we'll get the output y1n. If input is x2, we'll get the output equal to y2n. If we take the weighted sum of the output, this is the y1n and y2n, then we'll get a times y1n plus b times y2n, that is the a x1 square, a x1n square plus b x2n square. If we take the output due to the weighted sum of the inputs, that is this is the one input and this is the another input. So that means that transformation of the a times x1n plus b times x2n, that is the a times x1n square plus b times x2n square. We can easily see that both the results are equal. Hence, 1 is equal to 2. So we can say that the system is linear. Another example, that is y of n is equal to x square n. Here we can see that y1n is equal to x1 square n, y2n is equal to x2 square n. If we take the weighted sum of the output, we'll get a y1n is plus b y2n is equal to a x1 square n plus b x2 square n. If we take the output due to the weighted sum of the inputs, then we'll get the transformation of this. So we need to replace whenever n comes by this linear combination. So we can easily see that if we replace it here, then we will see that a x1n plus b x2n, that is we are replacing xn square. Clearly we can see that in this case a1 is not equal to 2, and hence we can see that the system is non-linear. Hope that this practice example and this explanation might have cleared your concepts about the dynamicity, causality and linearity of the systems. Before coming to class, you are advised to go to the literature and come out with the solution of the questions defined as above. Thank you. Hope you have enjoyed this section.